And we are live.
Good morning, good afternoon, good evening, wherever you are. My name is Dr. Robert Lustig. I am here with my good friend and colleague, Dr. Dale Bredesen, and we are here to talk about Dale's newest release, The First Survivors of Alzheimer's, released just last week. Dale, why don't you give the audience, a capsulized description of why you wrote this book?
Yeah, thanks so much, Robert. Great to talk to you as always. And by the way, I'm absolutely loving Metabolical. It's really the story that needs to be told. So thank you for that tremendous contribution. So I wrote this because we started with doodlings on a yellow pad back in the in the 70s and 80s, and ultimately in 2014 publishing the first examples of people who reversed their cognitive decline using a programmatic sort of precision medicine type of approach. And there are now hundreds of people who have reversed their cognitive decline. And so the stories are really compelling. And so as we started hearing these and about what it did to families and people who were told that there was nothing to be done and then turned around and went back to work and we're doing things again productively and realized that we can end it with this generation. Their families were not going to be affected in future generations. This is just fantastic to hear, and I know you hear similar sorts of stories about the diseases that you deal with. And of course, Alzheimer's has always been a death sentence. As they say, this is the area of greatest biomedical therapeutic failure. So I thought it would be wonderful to bring together. There are 7 first-person stories, and people talk about what happened with them, what happened with their families. And then a little bit more on where things stand with the overall protocol that we've been using and where things are going. So this is why I wrote the book. I wanted to give people some inspiration, but also some guidelines. Here are the things that actually help the most for these people. So that's why we put the book together. And as you said, just came out a couple of days ago.
So, listen, Alzheimer's is a disaster for the patient, of course, but even more of a disaster for the family. You have reduced virtually everyone in the family to chronic caregiver. And it has economic, it has social, it has financial and medical ramifications. And the worst part is that the family members say, am I going to get it too? This is the nuclear bomb that goes on, off in the kitchen. And I understand that. So I think, our audience would probably be very well served to sort of hear maybe one story, start to finish, from the book that, sort of tells the story of why what you're doing is so important.
Yeah, thank you. So let me give you one of the 7 examples. Sally is a woman who is a nursing professor in South Carolina. And she taught, in fact, in her classes that there's nothing to be done about Alzheimer's. Unfortunately, she developed it herself in her late 60s and actually went in and got evaluated. She has the ApoE4 allele, so the most common gene associated with Alzheimer's disease. If you have a single copy, about 30% lifetime risk, which she had. And she was getting to the point where she would forget, for example, to pick her granddaughters up. She would forget many of the things around the house. She could no longer do her job, et cetera, et cetera. And so she actually went in, was evaluated, and was told, okay, you need an amyloid PET scan, which she had, which was clearly positive. So they told her, yes, you've got the gene, you've got the PET scan, you've got early Alzheimer's. Thankfully, it wasn't so far along that she had lost her activities of daily living yet. But they then said, look, you need to go on a drug trial, which is what people typically do. She went on an anti-amyloid drug trial. And actually, with each injection, she got worse. And we've heard this from a number of people. Amyloid in our laboratory research and that of others is suggested to be a response to these various insults, including metabolic insults and toxic insults and various pathogens and things like that. So she continued to go downhill. And luckily, unfortunately, other people haven't done this as often. Luckily, after the 6th injection, each time she would go down and then she would slowly come back to almost where she was. She'd go downhill again and slowly come back. After the sixth injection, she said, "This is clearly hurting me. I'm not going to do this anymore." And her husband actually found out about the research we'd been doing. And I got an email from her. So I worked with her physician to get appropriate evaluation, appropriate treatment, because there are a number of things that need to be done. As you know, we now need larger data sets. You need to ask what is actually causing the cognitive decline, instead of simply saying, we call this Alzheimer's, we don't know what causes it. She has now gone from a MoCA score of 24 to a perfect 30. She's doing very well. She's back to remembering. Her granddaughters are very, very happy once again, because they heard that she had Alzheimer's and that she was going to die. And she's basically back to normal, doing very, very well, living with her husband, doing all the appropriate things to improve her insulin sensitivity. And interestingly, in her case, one of the numbers of contributors turned out to be exposure to mycotoxins. Now, interestingly, these are toxins made by specific mold species, such as Stachybotrys, Aspergillus, Penicillium. Those are the big three. This is not even recognized as a cause of Alzheimer's, but in her case, it was clearly one of the several contributors.
Sadly, it's not even thought of as a cause of anything in most cases. And, I've sort of learned a lot about mycotoxins in part because of the Integrative Medicine Mental Health Conference that I've attended, and also our own personal issues, in my family. So I get it. What do you think for Sally was the single most important thing that she changed that made a difference?
For her, as you know, it's always the appropriate combination, but probably the single most important for her was getting out of her constant exposure to mycotoxins.
So
She
basically
actually
changing her home.
She went from a place that was full of mycotoxins to a place that has very, very low mycotoxin levels. And for her, that was probably the most important. But what you bring up is a really critical point. For most of these people, there are multiple contributors, but there's often one or two that are the rate limiting steps. And until you address those, these people do not get better. And in her case, addressing that clearly helped.
So this is where things get a little, hairy. And and I have heard the, shall we say, the peanut gallery, throwing their peanut shells at you, for quite a while now. In your first book, The End of Alzheimer's, and we'll talk about the story of that title in a minute. But in that book, you liken this to a house with 36 holes in the roof.
Right.
And you're not going to have a dry house until you fix all 36 holes. And on any given day, you're not going to know which hole is causing the leak. So you got to fix all 36. That's kind of a big nut to crack for most people, especially when they don't know what the hell you're talking about, like mycotoxins. Insulin resistance is almost, now in the, shall we say, in the blogosphere and the zeitgeist.
Right.
That's almost like a given. But, how do you make the argument for these patients that they have to ultimately do, all of these things, because you're not sure which of these things might be the actual problem for them?
Yeah, Robert, this is such an interesting point because it gets to how we physicians all practice. And I was trained as a classical neurologist and neuroscientist, spent 30 years in the laboratory looking at what's actually driving Alzheimer's. And, unfortunately, just as Anthony Fauci said about COVID-19, the virus is dictating to us. We're not dictating to the virus. And as someone who's just getting over the Delta variant, despite vaccination and despite precautions, I can tell you, that's the truth. And it's the same thing with Alzheimer's. That's what's dictating to us what the problem is. And so if you're an expert in this area, you're already far down the hole and you say, next drug, next drug, next drug, we'll get to a drug one day. But if you step back and say, how does this disease actually work? Okay, there are multiple things. Human brains are complicated, as you know very well. And so therefore, you need to take a deeper data dive. And as right now, if you go to a classical Alzheimer's center, they'll look at a few things. They'll look at your TSH and they'll look at your B12 and just a couple of things like that. Well, that's not enough. You need to look at all the different things, the 36 holes in the roof, as you said. And then you need to see where are the problems and address those. Now, this is completely different from what is going on in mainstream medicine. And so just as you came to the conclusion that food was a huge part of what was going on with your pediatric patients, I came to the conclusion after all these years in the lab, and we published over 220 papers during this time, looking at what causes the phenomenon of neurodegeneration biochemically, genetically, microbiologically, toxicologically. Then when you do that, you see that this makes sense. And one of the experts the other day criticized us and said, oh, this is just common sense. Okay, this whole field needs a bit more common sense. The idea of treating something like Alzheimer's that has been untreatable in the past by giving a single drug for a complex problem makes no common sense. So the idea of finding out what's actually driving it and then addressing all of those things, you're changing network function. That's the bottom line. So that's the way to go about this.
So let me pose a thought to you.
Yeah.
There are a lot of different substrates that ultimately lead down the same road.
Yes.
Right? But it's because it's called Alzheimer's disease,
right,
that people think, oh, there's one cause, one pathway, therefore one treatment. And I think this is, sort of derailed us in this respect. Would it make any more sense for us to be calling this Alzheimer's syndrome?
Absolutely. And it should be called Alzheimer's syndrome. And that's been one of the problems. So just as you can end up with cancer for many different reasons, or heart disease for many different reasons, you can end up with this neurological degenerative condition we call Alzheimer's for many different reasons. But the good news is there are really only 4 groups of things. So you can literally write an equation. Your probability of developing Alzheimer's is proportional to an integral, and you've got these 4 things. So number 1, anything that causes ongoing inflammation. So this could be pathogens, it could be leaky gut, it could be a poor oral microbiome, chronic sinusitis, metabolic syndrome, anything that causes inflammation. Number 2, anything that is toxic, and that's inorganic toxins. So those of us in the California fires, we are at increased risk. Mercury, all sorts of inorganics. Organics, things like glyphosate and toluene and benzene and formaldehyde. And then, as we talked about, the mycotoxins. Third group of things, energetics. You've got to support your brain. You've got to have blood flow, oxygenation, which is, by the way, why so many people with sleep apnea develop Alzheimer's disease. So people should get checked for that. And then the third part of that is mitochondrial function, and the fourth part is ketones. You need to have something to burn, and you need to get into you need to be metabolically flexible, as you well know. And then the last of the 4 groups is trophic support, and that's nerve growth factor and BDNF, the things that increase with exercise, and then also hormones and nutrients, vitamin D, vitamin B12, and many of the things, by the way, that increase your risk with COVID-19 for a poor outcome also increase your risk for Alzheimer's disease.
Well, and we know for COVID-19 that the demographics of the people who are most likely to die, people of color, the obese, and pre-existing conditions. The thing that those groups share is ultra-processed food. And of course, ultra-processed food also contributes to Alzheimer's.
Yes.
So there's a remarkable overlap between what I do and what you do. In fact, probably because we are talking about multiple substrates, but ultimately single common pathways.
Yes.
Which brings me actually to a question. That is important to me, maybe not as important to the audience, but let's go there. In my book behind me here, Metabolical, I describe 8 subcellular pathologies that contribute to chronic disease. and I'll just name them real quick, but I want you to remember those 8. Glycation, oxidative stress, mitochondrial dysfunction, insulin resistance, membrane instability, inflammation, methylation, and autophagy. Of those 8, which do you think are the most important for Alzheimer's syndrome, and which do you think are less or not non-important for Alzheimer's syndrome?
Yeah, well, unfortunately, all of them are contributory. And I think that's been pretty well shown. Now, some of the, when we start to look at this with fresh eyes, one of the things you see is there are things that are important, but they're more downstream. So reactive oxygen species, oxidative stress, is a downstream event in Alzheimer's disease. Yes, it occurs. Yes, it's part of the overall process. But when you interrupt it, you get a very modest impact on the disease itself and on the associated neurodegeneration. On the other hand, insulin resistance probably at the top of the list. And here's why. When you look at those 4 things that I just mentioned, insulin resistance contributes to all. So for example, you've got increased inflammation because you have non-enzymatic glycation of protein. So just what you were talking about, glycation, multiple problems there. You have some toxicity associated with that. You have immune responses associated with it, but you also get the double and triple whammy because you now have a lower response to insulin. And when we used to grow neurons in a dish all the time in the lab, we always had to include insulin in the medium because the insulin is such a critical growth factor and supportive factor for neurons. So now not only have you altered the metabolism, but you've also altered the trophic activity for these. They are not supported as well. And to some extent, this change that you see, you're going from a synaptoblastic state where you're supporting and making new memories, new synapses, to a synaptoclastic state. You're literally driving your amyloid precursor protein into an alternative form of signaling, which is a protective downsizing mode. And again, there's a perfect analogy to what happened to all of us in COVID-19. We were all told to social distance, to shelter in place. We pulled back, we went into a protective mode, we didn't go into work, and the country went into a recession. This is exactly what's happening in your brain when you see these various insults and you go from a growth and maintenance mode to a protective downsizing mode. And the amyloid that you're making is part of the protective response, and it's actually part of the innate immune system's response. So I would say of anything, the insulin resistance is the most important one and extremely common. As you know, something like 80 million Americans have insulin resistance, and you would know this better than I.
Oh, it's more than that. It's 88% of all adults have some form of metabolic dysfunction, which was measured through the fasting insulin. So, I mean, we are all at major risk. So that actually leads me into, sort of my field. And let's talk food for a minute.
Yeah,
okay. The relation between food and Alzheimer's and the specific mechanistic effects of why food might ultimately impact Alzheimer's. Okay. Because food, at least, is something that's relatively changeable, malleable for people. Okay. As opposed to, moving. And I mean, that's a tougher one for some people, and getting, and changing their water supply. That's a harder one. But, everyone could change their food if they chose to.
Yeah.
Okay? Even people on food stamps could change their food if they chose to. So let's talk food for a minute. So number one, I have heard, from all of my colleagues at UCSF that there's a difference in energetics between the alpha helix and the beta sheet. So all of these proteins that make up the Alzheimer's plaque are normal proteins. It's not like they're making abnormal proteins. They're just being folded in an abnormal way to form these protein aggregates. So the alpha helix is a higher energetic state. The beta sheet is a lower energetic state. When an alpha helix protein ultimately beta sheets, what that infers is a loss of cellular energy. that somehow mitochondria are not making the amount of ATP that they should. Is that a fair statement, or am I reading too much into it?
I think there's a bit more there, but I think it's an interesting point. But as you know, one of the problems is in foldases, and literally how, what's going to fold your proteins and then what's going to degrade them. So there is this incredibly interesting relationship between going from building to going to protection. You are literally switching modes. And as you know, cells have these multiple modes that they go into depending on what's going on. And you're absolutely right. Energetics, critical for that. But beyond that, it's also about when you're going to break them down, how are you folding them? What are you using them for? Where are you putting them? And how do you break them down? And interestingly, these beta sheets, and this is very much in line with the prion hypothesis of your colleague and my mentor, Dr. Stanley Prusner, and
that's where I got it from.
The Nobel laureate. And so, fantastically interesting.
By the way, people thought he was crazy at first too.
When I was a postdoctoral fellow in his laboratory and I first got there, I went to one of his lectures and people were literally walking out the back saying, there's no evidence for this, there's no evidence, because he was saying something completely novel, that you can actually get a disease that can be transmissible and have no DNA and no RNA. And here it's this protein, and people said that's crazy. But of course, he turned out to be absolutely right. But what's interesting is this really gets us into the area of how are these things, what is the role of these things? In most likely, you're not catching Alzheimer's because you breathed in someone's prion. Now, maybe that'll change, but so far it doesn't look like there's any evidence for that. So what's the role? So what it looks like is this is not the upstream cause. This is a mediator. So what we've suggested is that these prions are the way that you get biological signal amplification. So as you know, when you've got to amplify a signal, and a great example is when you've got to clot your blood. If a cave person cuts off his finger accidentally, if he doesn't clot his blood pretty quickly, he's going to die. And so you have this beautiful system that feeds forward instead of homeostasis feeding back. So it's a positive feedback, and you rapidly make sure that you get this clot with a system of serine proteases. The same thing is true for prions. It's a rapid amplification system, probably related to neuroplasticity. And so then you've got to break it down. And one of the things that you can see that's beautiful here is that when your body is in an inflammatory state, when you have Alzheimer's or when you have COVID, then you can actually see that your A beta is not picked up by your macrophages. They refuse to take it up because you're using it. You're using it because it's a beautiful antimicrobial peptide. As you said, you change folding so that it has an antimicrobial effect. As soon as you start to get healthy and now the inflammation is down and you're doing better, now you go and gobble it up and get rid of it. So the same thing happens in your spinal fluid. You don't put as much. That's the hallmark of Alzheimer's. So you do this again and again.
So this then leads us into questions about other dementias in a way.
Yes.
So the getting rid of it, okay,
Yes.
that's a phenomenon which I write about. That was number 8 of my 8.
Right.
Okay. Autophagy is garbage night for the cell. That's how I describe it. If let's say garbage men go on strike, your house, for a week might be fine. After 2 weeks, it might smell a little bit. After 3 weeks, the rats come. After 4 weeks, pipes are going to start to burst. And after 5 weeks, you're going to have to move out of the house. You got to clear out the garbage. All right. And autophagy is the way cells basically recycle used, spent, degenerated cellular contents. That autophagy presumably would be going on to clear out protein aggregates, such as A beta or tau, but it's not. So there may be something wrong with autophagy. Now, one of the things that's been shown to promote autophagy in the brain is sleep. And the one thing that Alzheimer's patients don't do is sleep.
Right.
And one of the things that promotes autophagy is intermittent fasting.
Mhm.
And it seems like when people start getting Alzheimer's, they actually eat more, in part possibly because their reward system is, sort of in overdrive because their prefrontal cortex is not inhibiting their consumption. And so they're getting a dopamine response. They sort of, so my question is there something that we can do to try to improve, to try to, mitigate this problem, this pathway, and sort of stave off Alzheimer's
Yes, but first let me just
or
comment
other
on
or other dementias.
yeah, and let me just comment on what you said. So when you really look at it, Alzheimer's disease at its most fundamental nature is a disease of insufficiency, and this goes right up your alley, that is born of excess. That's the irony, and that's the tough part. People have an insufficiency of all the things we talked about, the energetics and the trophic support and things like that, because they have had this excess of carbs, basically. They have put their body into a metabolic state that doesn't clear these things out, and it now has inflammation. And what's interesting is this idea of autophagy, getting rid of the amyloid. We think of amyloid as bad. It's not that simple. Amyloid is good in that it is an antimicrobial. So the way to clear it out is to get rid of the things that are causing it in the first place, be they mycotoxins, be they metabolic syndrome, what have you. As you clear those, now your autophagy is kicking in. And you mentioned, how do you improve autophagy? Absolutely. You want to make sure to have a fasting state of somewhere 12 to 16 hours. You want to make sure to have sleep. And with the wearables, it's great. It's easy. You can check to see if you've dropped your oxygenation while you're sleeping. And if you don't want to do that, do it with a little oximeter or borrow it from your doctor or go in and have a sleep study. You can even buy a little oximeter for about $30 or so. So easy to find out if you're dropping your oxygenation. And then find out if you've got ongoing inflammation. Find out if you've got changes in your oral microbiome. All of these things are feeding into your body's desire to hold on. You were talking about the garbage. Great point. But now let's add one piece. Let's imagine that garbage that's flowing out is including, the guns and the bullets that you're going to use when you've got these pathogens attacking you. Your body is under attack when you are developing cognitive decline. So you don't really want to throw out the guns and bullets, and you're going to hold on to this stuff more until your body says, okay, Rob, things are better. Go ahead and let those go. And let me if I could ask you one question, because this is something that's come up recently that I think is really critical. People have complained that, hey, if I'm going to do some intermittent fasting and get myself into a better metabolic state, am I not going to increase my body fat? And people are worried about their body fat content. Is that a concern you have when your patients go into an intermittent fasting?
No, if anything, it's the opposite, because what you're doing is by improving insulin sensitivity, which occurs because of autophagy. Mm-hmm. You are actually bringing your fasting insulin down, which means there's less insulin at the adipocyte to drive energy into fat. So, intermittent fasting is, a tried and true method for weight loss. I'm for intermittent fasting. The reason intermittent fasting works best is because it gives the liver a chance to clear out the fat that has accumulated over the previous 16 hours. And when you get rid of the liver fat, your liver becomes healthy, and then your insulin levels go down because your pancreas doesn't have to work as hard to make the liver do its job. So that improves insulin sensitivity everywhere by improving what's going on in the liver. So my question is, why did that liver fat accumulate in the first place? And that's because of your crappy diet. And if you didn't eat a crappy diet, you wouldn't need to intermittently fast.
Yeah.
So that's why I think it works best. But yes, it does seem to also promote autophagy. So the concept that the brain is under attack now by microbes, you said, And this is very interesting
Among
because
others.
we usually think of the brain as being protected, that the blood-brain barrier prevents that. However, there was a paper that came out in 2019 that sort of shook my world and actually shook the dentist's world the most. Was this paper in Nature that said that they could find the DNA of a specific mouth bacterium called Porphyromonas gingivalis in the brain of patients with Alzheimer's. And then they did an animal model where they introduced Porphyromonas gingivalis and got an Alzheimer's-like pathology in those mice, suggesting that somehow, some way, what goes on in your mouth ends up in your brain.
Yes.
And I guess the question is, what up with that? Number one, and number two, what do we need to do, or how do we need to manage our oral health to influence our brain health?
This is a great point. And when you and I were in medical school, we were taught that the brain is a sterile organ. You don't find stuff in there unless you have things like herpes simplex encephalitis, which is a raging infection. But in fact, the surprise is there is actually a microbiome that includes the brain. Now, the jury's still out. Is it normal to have at least some of these? Is it always abnormal? Here's what the neuropathologists have found in the brains of patients with Alzheimer's. P. gingivalis, you mentioned, T. denticola, other oral organisms, herpes simplex from the lip. And in fact, beautiful studies out of Taiwan showing that people who treated their recurrent herpes in midlife had more than a 50% reduction in their likelihood of developing Alzheimer's, just striking changes. Wow. HHV6A, so other herpes family members, Candida, and also other fungal species. And other spirochetes, Borrelia as an example. So it is a zoo in there, unfortunately.
Well, all spirochetes are, problematic. I mean, we can pick our spirochete of choice.
Well, and as we say, this is the syphilis, the neurosyphilis of the 21st century is Alzheimer's disease. You've got these different organisms getting into your brain. And here's the interesting feature about this. My feeling when I first heard this was, well, why aren't we getting encephalitis from these things? So there was a beautiful experiment published a couple of years ago where they looked at the multiplicity of infection. They basically took a bunch of neurons and started putting some herpes. Now, no surprise when they would get a raging herpes infection. When they got down to one herpes for 1 million neurons, they got something that looked like Alzheimer's. So these are very mild, very chronic, smoldering attacks, which you have covered over. You're doing the same thing that bees do with propolis. They make stuff to cover the bad stuff that keeps it sterile and they make it so that there is a barrier. That's what amyloid does. It is an antimicrobial that gives you a barrier and allows the rest of your brain to do fairly well. And so that's why people can deal with, they have amyloid in their brains for years.
All right, wait a second. Hold on. There's amyloid in the heart.
Yes.
There's amyloid in the beta cell.
Yes.
Okay. What's it doing there? Is it protecting against infection there too?
I think it's likely. Now, of course, it's a different kind of amyloid typically. This is A beta is the one in the brain, and A4 amyloid is often the one in the heart, as you indicated. My guess is it's the same sort of thing, because again, when we were medical students, we were taught when someone has an amyloidosis, look for chronic infections like tuberculosis and things like that. Maybe the person has a chronic infection. And I do think, we've entered an era where it's not just about infection, no infection. It's about microbiome changes. And you mentioned the oral microbiome, one of the most important, because those organisms do gain access to your brain. And let me just throw in one other amazing experiment.
Through the trigeminal nerve, or?
Yes. Well, these, it's not so clear. The herpes, it's absolutely via V3 for sure. But with the oral microbiome, it's not so clear how they get it. Presumably it is trigeminal, but it's not so clear. Same thing, of course, going on with the nose and with the olfactory bulb. And of course, that's a big issue with COVID-19 as well. But there was a fascinating experiment published where the idea was, let's inject Candida, common thing, we're all exposed to Candida, into mice, and let's see how long their blood-brain barrier excludes it. Is it forever? Is it a week? Is it a month? The answer was about 5 seconds. So Candida injected into the blood is able to cross the blood-brain barrier virtually immediately. And the changes that respond to this look very much like the earliest changes of Alzheimer's. So again,
and the funny part is that Candida has been associated with various neuropsychiatric symptoms, perhaps for this reason.
Yeah. And so the bottom line again is your brain is protecting itself. What we see as Alzheimer's, when people remove the amyloid, this is like removing the granuloma in leprosy. You're not affecting the organism, you're removing the body's response to the organism. And that's the issue.
Well, that puts a completely different spin on it. On the other hand, in a way, it actually makes things worse, at least, from the standpoint of like, what are you going to do about it? Because, that means we're under constant attack and constant threat. So the only thing you can do, I suppose, is fix the 36 holes in the roof, which,
exactly.
Which is what you're proposing. So I want to use the rest of the time to address shall we say, the elephant in the room. Now that we've sort of gotten the science out on the table, and we know what we're talking about in terms of the pathology and the mechanism, or the mechanisms, I should say, 36 of them. You have taken it on the chin for, number one, the title of the first book, because it clearly wasn't the end of Alzheimer's. And I know who did that, and it wasn't you.
Mutual friend.
Yes, and it wasn't you. And you have also taken it on the chin for being, shall we say, a little too hopeful. And for being actually flippant about this concept. Why do you think that you have engendered such animus from the normal, I put normal in big quotes because I have my own bones to pick with the medical establishment. Why do you think this generated such a furor? And what would you say to your shall we say, former colleagues that have given you such grief?
This is a great point. Well, we're all living through the 21st century medical revolution. And I wrote about this in the new book. This is the bloodiest revolution in history because people are dying because we are not embracing new medicine. So 20th century medicine, which is still being practiced virtually everywhere, is about what is the disease, and then you write the appropriate prescription or you send the person to surgery. That is the way you and I learned in medical school how to treat and evaluate patients. You get a small data set and you look and say, oh, what's your sodium? What's your potassium? You got Alzheimer's. There's nothing I can do about it. Here's a drug, and it doesn't work very well. And of course, as we started to look, and again, I'm coming straight from the test tube. So we're looking at all the different features and we're saying, aha, okay, if we're going to treat this previously untreatable disease, number one, we're going to need to know more about each patient. Let's not treat blindly. So again, this comes back to common sense. Why would you try to treat something without knowing what's causing it when it's been so, as you know, so unsuccessful? This has been the disease that people haven't been able to treat. And this is why we were excited about it. So that's the first thing. We need larger data sets. Second thing, let's treat the upstream causes. And again, this is part of what's been called precision medicine, functional medicine, integrative medicine, P4 medicine from Lee Hood's term. And I think, Lee is a very, very smart scientist, won the Medal of Science from President Obama, invented the DNA sequencers for the Human Genome Project, tremendous visionary. As he says, you need to be a determined optimist to change the world, to change things. And he's really a tremendous role model for so many of us. So as we could begin to see that we need to think about this disease differently, we need to understand it differently, we need to evaluate it differently, and ultimately we need to treat it and prevent it differently. I did start, by the way, I didn't just start flippantly. I started with the NIH. I was on the NIA Council for the National Institute of Aging, and I presented this way back, 2008. And the response was, okay, but this is not what we know about Alzheimer's. We got to give a drug. It's, okay, yes, fine. This is a crazy new idea. Okay, no, but zero interest. We then tried to get funding for this sort of approach. Zero interest. We then tried to go out to people and talk to the experts. Zero interest. So, okay, finally we say, okay, let's at least, we tried to do the first clinical trial. That was now 2011 was our first attempt at a clinical trial. And again, zero interest. They said it's too complicated. You shouldn't be doing all these things. Just do one drug. Well, that's not the way the disease works. And that's why you failed all these times to get a result, because you're not addressing physiology. Just as if someone says to you, well, Rob, how many of these ultra processed, hunks of pepperoni and pepperoni pizza should I have tonight? And you say, well, none. It's like, no, just tell me two slices, 3 slices. No, that's not the way you do this. And that's the problem we ran into. Everybody was assuming that it was going to be drug A or drug B. And we said, no, that's not the way this works. The drugs are going to be great. They're going to be very important as part of an overall protocol, but you have to get at what's causing. So finally, I was left with, well, what can you do when everyone is uninterested? Okay, you start to treat the first patients. You show that they get better. So we did when we couldn't get the trial, we did the anecdotes, published the anecdotes. 2014, 10 of them, 2016, 10 more, 2018, 100 more. And we finally got approved in 2019 to do a proof of concept trial. And that's been posted on medRxiv just a few months ago. 84% of the people actually got better with their scores. I mean, that's unheard of in Alzheimer's. And for comparison, if you take the new drug, aducanumab, you don't get better, you don't stay the same, you get worse, but it's at the very best 22% slower that you get worse. And you have microhemorrhages in your brain and brain edema. I mean, it's a horrible situation. And you pay $100,000 a year for that luxury. So we're doing something that is much less expensive, that gets at what's causing the problem, and that actually works. And so, yeah, we're proving it. And of course, we've been criticized because, well, why didn't you start with a phase 3 trial? Because that's not the way you do this. You start with anecdotes, you go to a proof of concept trial, and the next stage is you go to a randomized controlled trial. And we're in the middle, actually, of planning this randomized controlled trial. So that's the way, that's the way this is. Now, you mentioned the book title, The End of Alzheimer's. Yeah.
Before you get there, I absolutely want to go there. I absolutely want to go there. But you have 36 separate variables. How do you do a randomized controlled trial controlling for 36 separate variables? I mean, how does that even look? What is it? What kind of study does that look like? I've done 2. How do you do 36?
That's a great point. And by the way, I don't have them. Alzheimer's has them, and we're being driven by what Alzheimer's pathophysiology is and the way a human brain works. So yes, you're right. You cannot do every combination of these. There's no way. So what you have to do is to test an algorithm. The algorithm says, if this, then that, if this, then that. So you bring in patients, and this is what we did in the one that we just posted recently. We brought in the patients. We look, do you have insulin? What's your HOMA-IR? What's your hemoglobin A1C? What's your HSCRP? What's your C4A? On and on and on, looking at these different variables and saying, okay, we now have a profile for why your brain is degenerating. We're going to address the upstream problems. And of course, we're also going to give you some support to rebuild the synapses that you've lost. And when you do that, the results are unprecedented. Now, people get angry and say, how can you say these results are unprecedented? Well, look at them. Look at the results, read the papers, look to see the improvements in people. Now, it's not perfect yet. We know that. We're still working toward making it better and better. People in this last one, instead of losing, on average, you lose per year 3.4 points on a 30-point scale when you have Alzheimer's or MCI. These people gained 3.89 points per year. So they actually went up. And by the way, there's one thing that doesn't lie, and that's an MRI. These people had MRIs at the beginning and MRIs at the end of the trial. And their gray matter, which if you have Alzheimer's, your gray matter goes down about 4% per year. If you're normal aging, it does go down per year, small amounts.
Sure.
These people, it went up. These people were people with Alzheimer's or MCI, and they actually were gaining in gray matter during this trial. So there's no way to fake that. Their hippocampal volume, same story, although the hippocampal volume didn't go up, but it went down less than a normal aging person's hippocampus shrinks. Again, you can't fake that. So I think people need to be a little bit patient here. What they're really saying is they're upset because we're saying, the implicit statement here is you guys were wrong about Alzheimer's in trying to get a single drug, and we were right in trying to approach and deal with what's actually causing that. Of course, that's going to make people upset.
Well, look, we know that our lifestyle is causing type 2 diabetes, cardiovascular disease, cancer, fatty liver disease. I mean, why wouldn't it cause dementia too?
And it does, as you mentioned in your book.
And it does.
You've got a fantastic book there. Again, you're telling the story that needs to be told. But when you have people yelling at you and saying, what you're saying is ridiculous, and it's also obvious, that tells you, I mean, it's a joke. They're saying, what you're saying, it's totally crazy. And besides, it's obvious. Well, okay, then how can it be crazy and obvious? That's what we're running into currently.
So now tell me the story of the first title. What was your original first title? People always ask me, what did he call it? What would he want to call it?
Yeah. So, it's interesting. My wife suggested the first title, and it was Wit's End, because Wit's End describes the researchers. We didn't know what to do. We were at our wit's end, and it describes wit's end is what happens in Alzheimer's. It's the end of your wit. And I loved that title, and I submitted it to our friend Caroline, who said, nobody buys a book that is named Wit's End. So they decided at Random House that the title would be called The End of Alzheimer's. And so we had a huge argument about this, and we went back and forth. And I actually called my brother and said, who had been the governor of Tennessee, and it had been a businessman in his earlier life. And I said, okay, here are some titles. What do you think? And I gave him several. And he said, The End of Alzheimer's. That's the title. I said, oh my God, that's not what I wanted to hear. So I one final email to Caroline and said, please, we cannot call this The End of Alzheimer's. And she wrote back in these big letters, The End of Alzheimer's is the title. And basically, saying we have a contract, we're going to call it what we want to call it. So at that point, it was either pull the book and just say no to all that research, or just say, okay, go with it. We'll do the best we can. And by the way, my wife was angry. My family was angry. What are you going to do? My colleagues were angry. But,
I got it. Oh, yeah.
Stride.
I think you've taken more on the chin because of the title than anything else. And,
maybe so.
And I feel very badly about that, because I know I've gone through this myself. My book, this one here, Hacking of the American Mind, was not originally called that either. that came afterwards as well for the same reasons. I wanted to call that book The Agony of Ecstasy.
Yeah.
All right, but no one's going to read that either.
I hear you.
So it is what it is. But
here's one thing, though, the very interesting, with the trial we did, seeing 84% of these people getting better. What we now know is if people come in early or they get on prevention, Alzheimer's is now an optional disease. And I know that sounds crazy, but it's true. If you get on early or you do prevention, which we recommend for everyone, Nobody needs to get this disease. And here's the big problem. There are 4 phases. There's, as you know, there's a pre-symptomatic phase. Then there's a SCI, which is subjective cognitive impairment. You can fix those easily. Then there's MCI, which is the third of 4 stages. So people tell you, oh, you've got mild cognitive impairment. That's like saying to someone, you've got mildly metastatic cancer. It should be called late stage Alzheimer's.
It's also like NASH. You've already got damage to your liver, which is not going to go away because you already got some scarring. You just don't have full-fledged cirrhosis yet. You're right. It's a stage on the way to oblivion.
Exactly. And so we've got to quit calling these things early stage. Get in. That's part of the fact that we're all now dying of complex chronic illnesses. Get in early. You can look at these things if you bother to. You can look very early on. So let me ask you, what do you typically do to avoid NASH in your patients? And do you look with ultrasounds? Or do you just look at the ALT and AST, or how do you typically evaluate your patients?
Right. So the way we, because it gets very expensive, and you don't have a MRI in your back pocket for all of these things. The cheapest, simplest way to evaluate them is a waist circumference. Now, it's sensitive but not specific. So there are a lot of other things that can contribute to waist circumference. Then you go to lab tests, and ALT is your best arbiter of liver fat. But it doesn't necessarily tell you whether or not you've got inflammation and or fibrosis. So ALT tells you fat. That could be stage 1 steatosis, which could reverse. So the way to figure out whether or not the ALT is telling you, there's real inflammation, is you go to the next level of liver function test, which is a gamma glutamyl transpeptidase, the GGT. And if your GGT is high, that means you've got hepatocellular damage. So in the face of a high ALT and a high GGT, you're going to have to assume stage 2 or non-alcoholic steatohepatitis. The point is that you need to get the fat out of the liver. And if you don't get the fat out of the liver, you're not going to solve the inflammation. The question is, are you going to need more than that? And the answer then is, thiazolidinediones and certain antioxidants may play a role. And the people are working on LXR agonists, et cetera, big guns. Ultimately, the best way to diagnose inflammation in the liver is elastography, which is very expensive. And, by that time, if you need elastography, you're probably on your way to cirrhosis anyway. So, it's again, it's a spectrum, just like you described for Alzheimer's, and likely because they're really actually the same diseases. They're just in different organs.
Yeah. And you make a really good point. If you look at people with ALS, Lou Gehrig's disease, 70% of them by ultrasound have fatty livers. So again, these are, these are and not understood. These are systemic problems, just as you indicated. The wrong foods are giving us many of these complex chronic diseases that are killing virtually all of us. And now, as Professor Christine Yaffe from UCSF has shown, Alzheimer's is now the 3rd leading cause of death in the United States, and number 2 in the UK, by the way.
Understood. Well, we have shown, and not just me, but our shall we say, our cadre of sugar specialists, if you will, have shown that fructose, that sweet molecule in sugar that I've been railing against now for 12, 13 years, is actually 3 mitochondrial toxins in one. It inhibits AMP kinase, which turns on mitochondria. It inhibits ACAD-L, acyl-CoA dehydrogenase long chain, which is the enzyme that sort of gets fatty acid oxidation going in the mitochondria. And it inhibits CPT1 through uric acid. This is Rick Johnson's work from U of Colorado. And CPT1, of course, is the enzyme that regenerates carnitine, which is the shuttle for getting lipids into the mitochondria for oxidation. So what I say to people is processed food food? And they say, well, of course it's food. I'll be honest with you. If you think Cheetos is food, all is lost. I mean, that's sort of that's the red line. And the reason is the definition of food is substrate that contributes to either the growth or the burning of the organism.
Yeah.
And I'll buy that. That's good. Substrate that contributes to either the growth or burning. But what if that substrate actually inhibits burning? Well, if you're a mitochondrial toxin, you're inhibiting burning. Can you name a mitochondrial toxin that inhibits burning, that kills you? Cyanide. Yeah. All right. Well, this isn't quite cyanide, but in fact, the fact that it burns, 4 calories per gram when you throw it in a bomb calorimeter is irrelevant to what it does at the mitochondria.
Yeah. Now,
growth. Turns out my colleague in Israel, Dr. Efrat Monsanigo Ornan at Hebrew University, Jerusalem, actually showed how ultra-processed food actually inhibits growth. Yeah. Through changes in IGF-1 signaling, through changes in insulin resistance that actually inhibit growth. So all of a sudden, now you're talking about ultra-processed food inhibiting growth and inhibiting mitochondrial burning. So is ultra-processed food food?
As you've indicated in your book, it's poison. By definition,
it is. By definition. Yeah, and the point is, why couldn't it poison the brain?
Yeah. And it absolutely does. And I've got a burning question to ask you. I know we're short on time, but let me just ask you, because of your tremendous expertise in this area, lots of interest in things like metformin. Metformin is going to increase your AMP, but it's doing it because it's inhibiting your complex 1. Well, inhibitors of complex 1 are what give you Parkinson's when they're more significant, just as what you said with the cyanide analogy. So this is a milder inhibitor, but there is a paper showing that there's an increase in risk for people who went on it of Alzheimer's and Parkinson's.
Is that right?
So the question, it's one paper. Time will tell. So my question for you: do you like to put people on metformin, or do you try to get other ways to get a more positive metabolic? Because of course, a lot of people are taking it for its longevity effects. But again, you're basically inhibiting. It's basically saying, I'm taking in too much, so I'm going to inhibit some of what it would normally give me. What's your feeling about metformin?
Right. So first of all, Nir Barzilai at Albert Einstein's running a trial on metformin and longevity, and I totally understand that. And it makes sense because it's improving insulin sensitivity, and insulin resistance is such a big nut in this whole story, and it's tough to crack. And metformin is at least a way to crack it, but it's only working on the liver. The fact of the matter is insulin resistance is a systemic problem, not just a liver problem. It does work on the liver. It doesn't have that much of an effect on the muscle or other organs. So it has limited utility. On the other hand, it is something that works. And for the patients who have hepatic insulin resistance, metformin is a godsend. Okay. However, the question you have to ask yourself is, how'd your liver get insulin resistant in the first place? Mm-hmm. And I can pretty much sum that up in one word: sugar. And we showed many decades ago that if you keep consuming sugar, metformin doesn't even work. Yeah. Interesting. All right. Well, this is fantastic. You might as well just get off the sugar and see what happens then.
I got you. All right. This is fantastic. Thank you so much, Robert, for having me on. I really appreciate it. I love Metabolical and look forward to future discussions and all your great work. All right, listen, I am a big supporter. Look, we're all barking up the same tree. We've all identified the same processes as being the problem. We all have to stick together. And there's a group of us, and we will change medicine. We will change medicine. It's, like everything, it's a 30-year process to change minds. Yeah. So, and better outcomes, we'll do it. So seeing people get better, that works. So anyway, thanks again. Great. My pleasure. Stay safe. You too. See you soon. All right. Take care. Bye-bye.